Hi everyone, just checking that everyone can hear me. Hopefully you can. So welcome to the Blue Room. This showcase is structured around a series of drop-in sessions. So you can join the Red Room and then come back to the Blue Room at any point. It's completely flexible. You can drop in and out as you choose. And there's just a link in the chat. Let me know if it doesn't work. But all the blocks will be structured around a 7-minute presentation followed by a Q&A. We're just going to ask that you raise your hand in the Q&A session, or there is the Q&A tab that you can pop it in just so we can let the presentations run and then focus on the Q&A. So our first session will be Mervick, who is online from Arup, on managing resilient systems and adapting existing infrastructure, improving water supply resilience of Metro Manila. So Mervick and Adrian, it's over to you.
Hello, hello from Manila, and good afternoon, everyone. I hope you can hear me okay.
Yeah, we can hear you.
Okay. So I'm Mervick, Salamat from the water team of Arup, and it is my pleasure to open today's session. I'll be discussing about the adaptation of existing water systems to new challenges as one of the themes in store for you in today's showcase. Our Southeast Asia water leader, Adrian Marsden, is also joining the call. He'll be running the second session on Friday about this one, and we hope that you can also join us there. So to begin, next slide, please. And next slide, please. All right. So to begin, through Arup's work present in over 40 countries, we strive to make a positive difference in the world with our commitment to sustainable development. And against the backdrop of global climate change, Arup is focused on the strategic management of water, with over 1,000 of our water professionals collaborating to create a legacy of future-proof and value-adding solutions in the water sector. Next slide, please. And in the world today, a lot of water supply systems are under stress from the impacts of climate change, making it essential for infrastructures to adapt. For instance, by designing or upgrading treatment processes to cope with changing water qualities. But it's not a very easy thing to do because building resilience requires a holistic approach. And to do this, we believe that rethinking the way that we think about integrated water cycle can become a catalyst to increase water resilience. And this approach is summarized in Arup's Design with Water model, as shown here in this picture, that can be used to support all stages of projects from inception down to implementation. Next slide, please. The case I'll be sharing today is one of the rehabilitation projects Arup did in the Philippines. And here's an actual photo of La Mesa Water Treatment Plant 1 that experiences high turbidity events following strong typhoons. So water turbidities as high as 2,000 NTU are received, that is far from its average design turbidity of 20 NTU, and that consequently impacts plant operations. Now, working with our client and stakeholders, Arup was commissioned to carefully plan solutions and build resilience to prepare La Mesa for these extreme conditions. Next slide, please. So it's one of those very critical projects, as La Mesa is the largest water treatment plant in the Philippines, with a capacity of 1,500 million liters per day. So it provides drinking water to more than 6 million people. And for reference, that's about the entire west zone of Metro Manila. And La Mesa draws its water from upstream dams and watercourses, which explains why it receives varying turbidity levels at different times of the year. And since it was built in the 1980s, it still utilizes conventional sedimentation and filtration for treatment. And its seismic considerations are also dated, as the basis of structural codes today were established much later than when the plant was constructed before. So for this, Arup led the feasibility studies to increase the plant's treatment capacity and improve its earthquake resilience. Next slide, please. As for our approach, first, Arup tackled the challenge by assessing the conditions of the plant and identifying targeted improvements, such as addition of inclined settlers to existing sedimentation basins. That increased the treatment efficiency to 99%, even at peak conditions, and a full seismic retrofit design of the plant and buildings to withstand catastrophic seismic events. This process also opened up opportunities to embed sustainability practices in the existing facility as we prepared the concept design. So that included a 1 megawatt solar power generation facility and the recovery of backwash waters as additional water source rather than treating it as plant loss. Next slide, please. And so the main goal for the project was to ensure reliable water supply 24/7, even at extreme conditions. However, key improvements resulted as well as to an efficient process with an additional 9 million liters per day of recovered water. It reduced the chemical and power consumption. And with the introduction of solar panels into the facility, avoidance of around 600 tons of carbon per year. Next slide, please. So in closing, one of the biggest challenges we faced in upgrading existing plants is interfacing with the live assets. But what we did for this project was to carefully apply assessments in ensuring the safe delivery of the project and to see to it that design provisions were embedded in the requirements to maintain its operations throughout the upgrading works. And in our case, we could only work on one basin at a time during rainy season to meet these targets. Lastly, it was be very critical to the risk and stage the activities that may affect the reliability of the water supply. And for this, the project was named Project of the Year in 2022 FIDIC Contract Awards for its recognition in excellence of the use of FIDIC in the delivery of the project. That's it. Thank you. I'll bring it over back to you for any questions you may have from the room. Thank you.
Thank you very much. So as Mervick said, we're going to open it to questions now. If you'd like to raise your hand or pop them in the Q&A chat. Also, if you're able just to, if you do raise your hand, say your name and where you're from also when asking questions. Thanks. If not, we do have a couple that have been submitted beforehand. Start with that. Okay. So Mervick, one of the questions that we had beforehand was, what are the challenges of intervening existing critical infrastructure?
Yeah, this is one critical aspect of upgrading an existing plant is to ensure that we don't stop production. It's a lot of concessionaires were depending on the water supply for this project, and we had to carefully plan assessing the demand for the water and plan out our activities beforehand.
Okay. One of the other questions we got beforehand as well was, for the case of high turbidity events, how do you manage the trade-offs?
Yeah, so for our plant, like for example, the treatment process was designed to its maximum treatment capacity of like 2000 NTU. However, we do note that we had to match the sludge treatment facility to cater for not exactly the peak conditions, but also to balance out the capex that we have to put out to manage that situation. In those cases, the sludge treatment facilities can operate for longer during the peak conditions, but not in such a way that it's left idle for such a long time throughout the year when it's not needed.
Thank you. I think we have something in the chat, sorry. Nidhi has asked, is it correct that you only worked in a specific season for this?
A specific season meaning?
It's just whether your sort of plans were only done at sort of certain periods of the year or whether it's sort of running year round.
Oh, all right. So as we know that water quality tends to be worse during rainy season, we can only repair or upgrade one basin unit during the peak season. But the rest of the year, when water quality is quite good, then we are able to work on more segments of the plant as we should. But we made sure that we were continuing with our work throughout the year. Yeah, thank you, Nidhi. I hope that answers your question.
Yeah, I believe there's one additional question that's come through beforehand. It's about what would you say are usually the challenges to ensure 24-hour water services? Is it purely technical and is it a priority issue?
It does happen to us, especially in the Philippines, that we have to sort of like have a rotation of supply at certain periods of the day or of the week because of these problems. What we do prioritize is providing the quality of water that is maintained. It is quite unfortunate, and we do know that supplies is quite critical as of the moment. So we are working together with our clients to have those feasibility studies really implemented up to the construction phase, so we can provide more water and secure the reliability of water in the Philippines.
Thank you.
Thanks very much, Mervick. Thank you. We are now going to move on to our next module. But obviously, if you have any further queries regarding that, we can get you in touch with Mervick and Adrian at a later date. So next up, we have Tom Godfrey.
How do you want it?
Sorry, I'm just introducing Tom. So Tom is looking at nature-based solutions and the restoration of salt marsh using a circular economy-based model. So Tom, we will hand over to you.
Hi, good afternoon, everyone. Thanks very much for inviting me along. Yeah, so if you just, we're ready to go. If you just go through to the next slide, please. Yeah, so Earthchange is a division of Land and Water, and having just heard the previous presentation, I should note that Land and Water are a very big environmental engineering company, and in the UK at least, when there are massive floods or whatever else, the COBRA or the EA will call upon EA to figure out how do we how do we resolve big floods? So like the Somerset got flooded in 2014, and so the call came out and we helped them fix it. That's so Land and Water do all sorts of different things where land meets water. Earthchange, though, is a small division of Land and Water, and what we try and do is to figure out how do we innovate around the wholescape. The wholescape is basically where land meets water, and improve the value of water through building high-value ecosystems, and that would be wetlands, woodlands, wildflower meadows, salt marsh, and seagrass. Next slide, please. Okay, so we come up, we deliver a no regret strategy because and we say no regrets is because there are more and more there are all sorts of offsets being delivered, having to be delivered here in the UK. So whether that's nitrates or phosphates or water or biodiversity net gain, and the big issue is there's a lot of arable land being taken out of production to deliver these offsets, and we think that's wrong. We think food security is the most important thing here. So if you're going to deliver high value ecosystems, you do not have to put it on land which can be used for food, basically. And so we just work on unproductive land, and that land is everything from closed landfills, is intertidal areas, and also subtidal areas as well, which is where we do seagrass. If you go to the next slide. So the challenge, so what I'm going to talk to you about today is the salt marsh side of the business. So salt marshes, we've lost, in the UK, we've lost probably 60% of our salt marshes in the last 100 years. And as you can see, there's a lot more mudflats than our salt marshes. And what the big issue with salt marsh restoration is that there's heretofore there's only been sort of two methods to do that. There's managed realignment, where you knock holes in walls and do it, but if you're trying to restore sort of 10 hectares or something like that, much more difficult to do. And so we've invented a thing called the salt marsh restoration drag box, which allows us to pull sediment up, which is deposited by the dredgers. We pull that up to the shore, all the way up to where the existing salt marshes are, and restore the salt marshes, basically. And well, we create mudflats, I suppose, and then but the thing with salt marshes, they grow if the land is a certain amount above mean high water. So this is something that we did our first pilot. If you'd like to move to the next slide. We did our first pilot in Chichester, which is on the south coast of England, just near Portsmouth. And as you can see on the left, that's a sort of a map of how much we raised a particular area. It's a small area, it's just half a hectare to begin with. And then on the right there, you can see the finished salt marsh, which was way below that. So we've pulled the mud all the way, the sediment all the way up to the existing salt marsh. And I'm happy to report that about 2 weeks ago we had our first shoots of recovery, and so salt marshes are now recolonizing that. And so we hope now to we've got other projects now in Lymington and then in Poole, which is also on the south coast of the UK, and we're moving along here. Next slide, please. So just looking at sort of opportunities in here, and I've got a map here of New York. New York is only because it happens to be 50,000 square miles, what big, and that's how many salt marshes have been lost over the last 150 years. There's 22,000 hectares in the UK that need to be restored as well, and so there's massive opportunities to for this new technology to be used. We at Earthchange, as well as doing it, it was a full service, because there's a full service offer that we can have, which is everything from figuring out what the research needs to be, how we can improve the local marshes through the permitting all the way in to the maintenance of it as well. And for those of you who are not across all the different benefits of salt marshes, is that there's lots of stack benefits, and they are amazing at absorbing nutrients, nitrates and phosphates. They are incredible. 75% of the marine life spend some part of their life in wetlands, whether that is salt marsh or fresh water, and then there's other benefits as well. And so we have other innovations coming down the pike in terms. We've just automated the planting of seagrass as well, but what we're all about is innovative automation, which is driving nature-based solutions, which enables us or projects or governments or companies with real ambition to restore nature at scale. And we've come here today just because we are primarily UK based, but we're looking at international markets as well. Thank you very much.
Great, thank you, Tom. I think we're gonna again do the same format with questions. We have a couple that have been posted online in advance, but if anyone does have current questions, then please pop them in the Q&A chat. Sorry.
Go ahead.
Yeah.
Yeah. Okay. So yeah, we do have some questions that have been received beforehand. The first one is about the scalability of your approach and your views on that.
Yeah, so we're limited only by the speed with which we can manufacture drag boxes. Basically, the drag box itself is a Victorian invention in the UK, which used to dredge lakes here in the UK. The winch which pulls it is a Canadian invention, which pulls logs off 400 meters off the side of Canadian hillsides. And so we have. Land and Water is the company that, obviously it's a £50 million company. We have 250 odd employees. We would look to scale up, but we, through the manufacture of these, as well as probably partner people in different countries as well, if we're going to offer some sort of full service, because we couldn't begin to permit and to do that side of it, but we could actually help. We would then probably just focus on the delivery of the particular project that was there. And these. What we can do just in terms of, probably we would do a hectare in a week of sediment. So that's the sort of speed at which we could move.
There is a second question, which is slightly related to the first one, about the limits to the nature-based solution, and can they be implemented anywhere?
Yeah, they can. Just because you're talking about this particular in salt marsh is so you don't actually, with salt marsh, you actually don't need to reseed or plant any salt marsh. It's literally the reason that it's generally gone is that there's been some sort of erosion or whatever else, and so therefore it's a matter of just lifting the height of it, and then it self-colonizes. And so nature does a great job all by herself. One of the things that we're looking as well is maintenance too, because of sea level rise and the areas along the south coast of the UK. It's pretty well used by pleasure boats and all sorts of different things. So there's wave lap and all sorts of things which as well as high nutrients in the water that has helped dissolve or erode the salt marshes. But yeah, so there's no problem with scaling and that side of it.
Okay, brilliant. And one final question, in terms of partnerships and what kind of partner would you need to develop your solutions with in a new country?
Yeah, so it's most of the challenge is permitting, and so it's companies we're looking for that understand how environmental law works in a particular country, that will have done, and therefore will have permitted, because I think most countries there is the pretty stiff legal barriers and local barriers. So both planning and permitting is where it is, and so they are the partners that we would look to work with.
Okay, thank you.
Right, thank you.
Thank you, Tom. Thank you.
Thanks.
Okay, so next we have Richard. Hopefully Richard's online. So Richard will be looking at natural infrastructure, again in nature-based solutions. So this is on preserving drinking water quality with nature-based solutions in St. Lucia. As we currently are running a little bit ahead of time, I'll just double check that Richard is here. A moment.
Hello, everyone.
Hello,
Would you
sorry,
like
we're
me
running
to...
a bit. We're running a bit ahead of time, I'm afraid. So,
Right,
but yeah,
okay.
so
Just hot-footed it from the other room.
wonderful. Okay, well, it is over to you now.
Okay, so hello, everyone. A little bit about me. I'm a civil engineer with 30 years experience in all over the water sector, much of it with Mott MacDonald. Started my career in rural water supply in East Africa, and I've been involved in all types of water development in Oman, Eastern Europe, and the UK. So I'm going to talk today about two nature-based solution projects. One in quite contrasting, one in St. Lucia, which is about catchment management, and a second brief mention of a project in the UK, which is about using nature-based solutions for water treatment. So next slide, please. Yes, so I think we can move on to the next slide. A little bit about Mott MacDonald. We're a global engineering, management and development consultancy. We've got about 18,000 staff across, I think it's about 135 countries at the moment. We're delivering projects of all types in the built environment. In particular, in the water sector, we've got about 100 years of history, and we cover the full water cycle and the environment sector in parallel. So perhaps we could move on to next slide. So a little bit about our approach to nature-based solutions. We have developed an approach which we use on most of our projects. Our initial step would be to develop a shared vision to understand what are the key KPIs that might affect the outcome of this project. Net zero, biodiversity, net gain, what are the social outcomes we're looking for, as well as what are the technical outcomes that are desired. That we then move on to identifying the options for nature-based solutions, and we would then look at perhaps the carbon credits, the biodiversity net gain, natural capital accounting, etc. We would then move on to the more traditional elements of the project, finalising the design, preparing for construction, and ultimately, and very most importantly, monitoring and evaluating the outcomes. So next slide, please. I think you might scroll through, yeah. So I wanted to mention an example in St. Lucia. It's an example of how we've used nature-based solutions to enhance a catchment. It's a relatively small project, but it's very important to St. Lucia itself. The city of Beaufort is growing quite quickly. Various development projects are underway. All of those projects will require more water. However, the city draws its water supply from a fairly small catchment, which is increasingly degraded and suffers from water scarcity. For example, there is detritus in the intake owing to agricultural practices. There is soil erosion. There is contamination within the river itself, leading to high turbidity and poor water quality. So one potential solution might be to upgrade treatment, water treatment, conventional water treatment. However, in this case, this is not a feasible option. This is too expensive, and it comes with a high carbon cost. So the Lucia government wished us to look at alternative methods. They want us to look at potential nature-based solutions. So next slide, please. So in order to see how those solutions might work in this catchment, we developed a fairly detailed catchment plan, and we worked closely with stakeholders in St Lucia to ensure that that model is accurate and, in particular, accurately reflects the way that that catchment responds to agricultural practices and increasing rainfall. We then developed a set of possible options, and those ranged from improved farm practices, small check dams, filter strips along the river to help filter runoff going into the river, lower turbidity, perhaps improve water quality, and also sediment retention wetlands. Now, having developed those concepts, those were then put to a range of stakeholders from the farming community, community organisations, and the government itself. And some agreement was reached on the type of options that would be considered, and then we put those in the catchment model to see how it responded. And the outcome of the model was able to guide the selected solutions. So as a result of this work, the St Lucia has chosen to implement a system of check dams, filter strips, and improved farm practices, and we're actively engaged in assisting them in developing that work. So the outcome has been a low carbon solution, working with nature to improve water availability and to improve water quality as an alternative to expensive and fairly carbon intensive water treatment, which might have been a more traditional approach. So if we could perhaps go to the next slide. So I wanted to contrast that with a project that we've been doing in the UK for Severn Trent Water. And this project uses nature-based solutions in a slightly different way. In this case, we're using them to enhance water treatment. So Severn Trent are building a new water treatment plant at Churchwill under something called the Green Recovery Programme. That takes water from the Trent, which is a heavily polluted river and has been problematic over the years for treatment. It requires quite a complex range of treatment processes to provide adequate treatment. So one way of perhaps reducing the amount of treatment necessary was to use floating wetlands. These wetlands are placed in gravel pits adjacent to the river, and the water passes through them on the way to the treatment plant. Now, by using these floating wetlands, carefully designed with the right types of plants, they aim to reduce, in particular, ammonia and nitrogen, which were two particular concerns and which have quite a high carbon impact during treatment. Now, this is a trial, So it is relatively innovative in the UK water industry to use floating wetlands in treatment. So Severn Trent are interested to see how effective these are in really reducing ammonia and nitrogen. So those trials are about to begin, and that, you know, they will guide perhaps further floating wetlands in the future, and it will be interesting to see to what extent the level of treatment can be reduced in the water treatment works at Church Wilne. So that's the end of my presentation, but I'd be very happy to take any questions if you may have some.
Thank you, Richard. I had a quick question, just about sort of the Severn Trent trials. So you're saying they're about to start. Do they have a rough idea of how long they will trial them for, or is it some of it is see how they go, see how effective they are?
It's a trial has already started, which is going to run for about a year, which is actually looking at the effectiveness of some of the more novel treatment processes in the water treatment plant. But that will be quite instructive in understanding the change in water quality in the gravel pits. The gravel pits have not been used as a water source for about 20 years. So there'll be quite a change in water quality in those gravel pits as water is drawn through them. So one of the objectives is to understand how that will change. And then over a longer period, the wetlands will be monitored. I would imagine over a period of years to see how effective they are in reducing the nitrogen and ammonia levels. Those levels vary quite a lot in the Trent. It's one of the problems that it's one of the reasons the Trent hasn't been used much for potable water, as a source of potable water until now, because it is so problematic.
Okay, thank you. I think Andrew's got a question, so I'll just pop his mic on. Okay. Andrew, if you'd like to unmute, then you can ask your question.
Thank you. Yes, great. I have a voice. I don't know if you can see my camera. Yeah, great, Richard. Thank you for that. It's really great to see some practical stuff on the ground. I'm interested in the St. Lucia example and particularly the return on investment. Who's paying for it? What are they getting back from it? Have you got some good economics? And the reason I ask is because we did a bit of a quick literature review of the evidence for our so-called best buys for nature-based solutions, and we found so few from developing countries. And if this is a case study that we could use and could turn into an academic paper, that would be brilliant.
Yeah, I mean, I don't have the exact figures in front of me, but what I do know is that compared to a conventional water treatment solution, this has far greater, you know, the cost to benefit ratio is far greater, and it has additional benefits outside the immediate water sector. It will have benefits to the farming community themselves within the catchment. So part of the work will be to quantify, that. So I think I could probably get some more information and data to you on that.
That would be fantastic. And I had another question, if I'm allowed. And that was about the sort of, how did you engage with all the stakeholders up and down the watershed? Was this a good example of collective action and multi-stakeholder engagement?
Yes, yes. I mean, it is. I mean, it was inevitably. It was through the St. Lucia water utility that the project was envisaged, but we brought in representatives from the community. It's a relatively small area, so we brought in representatives from the community, particularly from the farming community, but also from the agricultural sector within St Lucia. So to try and make it a proper multi-sector approach. And the way in which the options were chosen was based on a sort of multi-criteria analysis, if you like, with all those stakeholders.
Thank you.
Thank you.
Thanks, Andrew. I think we have another question.
Yes.
Bear me one moment. I'm just going to allow Jermaine's mic and camera.
Thanks. Probably quite strategic, keeping people from just butting in with their thoughts on interesting topics like this. I have a question. It's somewhat similar to Andy's, because we recently commissioned a review of nature-based infrastructure projects in Africa, and yes, there aren't very many, and a lot of them don't always have the fully costed models, since the maintenance modeling is quite different to traditional concrete infrastructure.
Yeah.
So I was curious if, as part of your work, you'd done any modeling of maintenance costs or how these might differ, because that's such an area of novelty for a lot of municipalities or governments that I feel like it
is. So yeah, that has been assessed as part of this, because we're interested in the whole life cost of the interventions. So I know that has been taken into account, and as I say, I think I can probably get some data on that. But certainly with Severn Trent, it's a crucial, which is a very different situation clearly, but it's a crucial factor for them, is the operation and maintenance of this floating wetlands. So that was a fundamental part of the evaluation of that particular solution, and will be something that is closely monitored to increase understanding.
That would be amazing if you could share the data, because I know, especially within FCDO, we have an increasing interest in understanding what those costing models and risk models look like across a variety of our programming. So that would be lovely if you could share.
Okay,
more.
I can see what I can see what I can see what I can find there. That would be okay. Pleased to help.
I have one question, if that's all right, Richard, regarding nature-based solutions in general. What do you think are the greatest constraints in terms of implementing these nature-based solutions? You've mentioned monitoring and trialing and monitoring of the solution. So is it purely a technical side of these solutions, or maybe as a result of that, is it a bit of a hard sell to clients?
Yes, it is. I think those of us who were involved understand that. I mean, I think we're going to see that in the UK with the approach that's taken to reducing flooding and sewage overflows. That there is a big opportunity there for more nature-based solutions. So yes, there is a hard sell, convincing engineers, like me, I suppose, but perhaps engineers who have had less contact with the solutions, and with clients who are infrastructure-led clients. I do think there is work to be done, but there are clearly so many more examples. We've recently been involved in a flood alleviation scheme in Leeds, actually, which used a lot of different nature-based solutions to enhance an engineering project, and that has had quite a dramatic reduction in the impact of the scheme on the local community and on its cost, and is effective. So I think examples like that are the way to advance more nature-based solutions.
Okay, thank you.
Great, thank you. I don't think there are any more questions. Thank you very much, Richard. I think there's a bit of a coffee break, so we've got about 15 minutes. We're due to start again at 4:35 if you would like to join here or again in the red room. See you all shortly. Thank you.
Thank you.
Thank you.
Bye.
Bye.
Hi everyone, welcome back. Just in case there's anyone that has just joined either this room or just joined the workshop as a whole, these are drop-in sessions, so you can flick between this blue room or the red room, and the link to the red room is linked in our chat. And the format is just sort of 7-minute talks followed by a Q&A for each presenter. So without further ado, I will pass over to Juan, who is looking at digital tools for resilience. Juan.
Thank you, Maya. So I'm going to introduce a couple of case studies. Welcome, everybody, first of all, about remote tools. In the last few years, we've seen increase in the usage of satellite imagery, and it's becoming more available, cheaper. So we are using it for different products and different projects, things going from dengue fever outbreaks detection to dam safety. So I'm going to show you 2 examples that related to dams and to some groundwater infiltration calculations. So hopefully that will give you an idea of the potential of these tools, which have a lot of advantages. How can I pass the slides? We need to click there. Okay. So the first case is called DamSap. DamSap is a software we've developed with the help of a number of organizations, including the UK Space Agency. And the idea of DamSat is to give a level of protection to dam owners and give them advice on maybe dams that are in difficult location or very separate to each other. So have a tool that helps to frequently monitor those dams using a combination of methods I will describe before. So what we are trying to avoid is what you can see here in this video, the Brumadinho tailing dam failure that happened a few years ago in Brazil. It caused 270 deaths, this event itself. And usually these type of events happen because of lack of monitoring on those dams, and suddenly they collapse, and with no warning, they affect people. So what we are proposing here with this tool is an operational system that helps you to monitor water and tailing dams. So in both cases, you could use it, mainly fed with information that it can derive from satellite images. So it is actually updated constantly, daily, or depending on the satellite that you are using. But covering a whole area, a very big area, so very sparse dams or very separate dams could be analyzed and providing a better understanding of the behavior. That could be combined as well with sensors inside. So if you've got sensor in the dams that maybe assess the movement of those dams or any other tools that we combine. We have some elements of artificial intelligence because some of the movements could be reasonable when they are needed to give you a warning. Then it's a matter of understanding the different characteristics and different circumstances that are happening there. But while we are using all these satellite images and all these sensors to put in a central hub in a website, all this information automatically. Some of these processes are done with no human intervention, but some of the analysis of the things that are happening can be done by experts, by dam engineers, that then can make a number of decisions and can make a number of actions, like with the objective of raising an alarm. We don't have time today, obviously, to go into all the technical details on how this works, but you can see some of the modules here: leakage detection, movement detection, hydrological forecast. These are all the things that we are analyzing with this system. And one very important part is the emergency planning. So understanding the consequences if one of these dams fails, what is going to happen. So we've got here, let's see if we can do it, a little video of the same dam we've seen in Brazil, where when you think that there is a risk of this dam failing, you can actually look at a hydrological simulation that it will be considering the dam breach evolution and the fluid dispersion of the water contained there. And you could also have the population, model it there, and analyze how the effect of this dam could cause and how different warnings, for example, in this type of simulation, we tested different scenarios, and we realized that just 15 minutes warning in the case of the Brazilian dam could have saved almost all the lives that they were lost. Okay, so this technology is enabling dam owners to control better the risk associated to these dams, and actually to raise awareness when something unusual is happening, and maybe give a warning that could save lives and reduce the impact of those failures. Okay, so I think it's an ideal tool for accessing remote locations, increase the frequency of analyzing those possible problems that you might have, and increasing the safety associated to those dams. Okay, we do have let's see if I can do it. We do have right now a place where we've been testing it. So we've got a live DAMSAT project working in Peru, where we are supervising 31 dams. There, it's been a great success, and I think we are really looking forward to expanding. We are talking with other countries to set up this DAMSAT in other areas. But yeah, if anyone watching this presentation wants to know more, I'm putting there the email of my colleague Tim, which is the project manager of DAMSAT, and there is also a website that I invite you to visit so you can check more information about DAMSAT. So then I'm going to pass to a different application of satellite images. This is a real project in Yemen, where we were trying to assess groundwater resilience. And what's the problem in Yemen? Basically, there is a huge problem of water scarcity, which is affecting food security. 80% of the population needs humanitarian assistance, so it's really critical, the situation there. And because of that, there's been an increase of the usage of groundwater. Because of the current conflict, it's really difficult to monitor any groundwater information on site. So it is very difficult for people to do any informed decisions related to this, and it's very difficult to prioritize any type of intervention. Because of that, we've proposed a solution where we try to actually assess this groundwater recharge and abstraction using satellite images. We've created a web portal where this can be seen. We haven't done it on our own. We've got a number of companies that have helped us, and we've collaborated with them to create this tool. And I'm just going to show you very quickly, obviously we don't have too much time, how this website looks. So it's just a simple website, very basic, but very simple, not basic, simple, with a lot of information that you can select on the left-hand side. And then there are some displays, GIS data that you can be showing it. So people that need to make decisions can see what is the information and the situation with groundwater recharge in different areas, with different land types, different agricultural land uses. And then we have in a central hub all the information available that it could be also analyzed by the stakeholders that need to make decisions there. Ideally, obviously, all these satellite calculation we've done would be double-checked or validated against observed data on the ground. We don't have that capability now because of a lack of access. So that could be refined, but it's much better than not having any data and trying to make decisions blindly, okay? So again, satellite images in this case is enabling us to create some tools and estimations on places of difficult access. This is not the Andes. This is not very hilly or difficult terrain to access. This is an area where there is a conflict and it is impossible to get access there. Okay, so I think that's it. I've gone over the time, but not that much. So if we've got any questions, I will be very happy to answer them.
If anyone's got any questions, please raise your hand, or again, you can pop it in the Q&A to remain. In one moment, I'll just enable your mic. There you go, Tremaine, you can unmute yourself now.
Thank you, and thank you for the presentation. I think I'd actually seen some of the Yemen work in another talk, but what I'd like to understand is how much data do you already require to apply DAMSAT, and how much can you rely on remote sensing? And I'm thinking in particular of either remote locations or locations where there isn't a lot of information, such as much of the African continent. Thank you.
Thanks. That's a really good question. One of the first things we do when we are setting up a DAMSat project is looking at first freely available satellite images, which there is a lot of it. And then we see also the budget constraints of our clients. We can look at maybe better resolution data, but you need to pay. And we do some sensitivity tests. We see how better the results or how similar they could be with two sets of data. And then according to the limitations of budget budget basically, and results, we give an educated suggestion to our clients saying, look, for you probably it's better to use the free data because it is much simpler and the degree of resolution you get, it is more or less similar. So coming back to your question, I'm divagating. This technology, because it's using satellite image, can be actually used anywhere in the world, even in places where you don't have any data. Obviously, if you've got then additional ground data, then that will be very valuable to double check, to verify, to cross check different sources of data. But if you don't have it, at least the data that you can get freely or paying from satellite will give you a first point to consider and analyze the problem that could happen. Okay. So at the end, we work with what we have, and the more data that you can put, the more tranquil or the more relaxed you will be about the accuracy of what you are producing. But in case of absence of data, it's better to use those sets than not using anything. Okay, so basically we can work anywhere in the world, even if there is no data. Like the example of Yemen, where we didn't have any ground data.
We do have a couple questions here.
Okay.
So is DAMSat being integrated into catchment and/or countrywide early warning systems? Because you mentioned about sort of having that 15-minute warning in Brazil and sort of that difference that made.
Yeah, I don't think that right now, for example, in the example we got in Peru, is integrated to any other system. Okay. But I don't see any reason why it couldn't. So eventually, what you are producing is an alarm system that they could feed other systems. Any other early warning system could be a signal that we could also use in DAMSat if that was required, because it could be considered as a sensor data, the outputs of other forecasting systems. We do have some hydrological forecasting tools inside of the tools. For example, if it's going to rain, we could estimate how much the level in the reservoir is going to increase. So we do some hydrological forecast there. But if you got something more complex, like a hydrological model, because there is a sequence of dams in a river or things like that, I presume that we could also connect other outputs from other warning systems or hydraulic models that they could be used into the system. There's
another one here. Do you use the groundwater tool enabling development of strategies in Yemen and other countries?
Yeah, definitely. That's the point. Exactly. So giving information, additional information for the people that can make those decisions. And it could be applied, the same methodology could be applied in any other countries. Ideally, in places where we've got also ground information, obviously it will be refined. It will be more refined because we could be comparing whether our hydrological models are giving us the right information, and we could tweak them. But if it's proven to be useful in Yemen, I think it can be useful anywhere in the world because we didn't have any information on the ground. So definitely, it's a tool that can be applied anywhere. Yeah. And maybe help you to make decision about what you could be cultivating, which crops, what type of strategies you can do to fight against these problems and help the groundwater to recharge more. Yeah.
And then the final question we had was, how do you see AI further contributing to dam monitoring in the future?
I think it is a really important aspect because signals from those sensors are in general very complex. And AI help us to understand better what are natural movements that the earth dams experience because of change of levels and things like that. And when you get into unusual areas or movements that you should be considering worrying, okay? So I don't think you can have a fixed threshold and you say this movement is bad or good. You need to learn from different levels and the history and seeing that happens before. And AI, it will play an important role. It plays already an important role in the tool to make decisions and helping people to make decisions.
Thank you. So it is you again. in our next slot. And this time you'll be looking at digital tools for efficiency through leakage analytics.
Are we starting right now, or do we need to wait on?
We can wait a couple minutes.
Yeah.
Yeah.
In case
Okay,
someone from another room wants to come or something.
Yep. We will leave a couple moments. Oh, sorry, Tremaine's.
Yeah, we can carry on.
I don't know if that was another hand raise from Tremaine. Go for it, Tremaine.
Thanks. I'm slightly notorious for my questions. Andy knows that terribly well. I don't know if this is the wrong thing to ask, but how much does it cost? Because we've had some really interesting presentations today, but I've realized there haven't been any stickers attached to it. So it would be great to know how much this kind of service costs and if there are different
Are we talking about
packages.
DAMSAT?
Yeah, DAMSAT, since I haven't seen your presentation to come yet.
Okay, to be honest with you, I don't really know. This is a question you need to ask to my colleague team, because I'm just presenting on his behalf. But I presume that it depends as well on the type of data you are using. So if you are using free available satellite data, it will be much cheaper. The product is already a mature product that is being developed. So this is not a research project that you need to pay for. The development of the tool exists and is commercially available. So I presume it will be relatively affordable. And then if the data you are feeding, it is freely available data, then the maintenance of the tool and the cost of running that tool will be much lower. So I think it's impossible to give you a book figure now without knowing exactly which area you want to, which area exactly, the size of the area you want to analyze, how many number of dams. But if we talk with Tim, send me an email or an email to Tim, and then we can give you an estimate based on the specifics of your project. We are not talking about multi-million-dollar tool. It's probably going to be something much lower than that. Okay, so it is an affordable tool, definitely.
Affordable is always in the eye of the payer, I find. So part of what really caught me on slide, I guess it's 41 of the pack, is the fact you can use remote sensing to estimate groundwater recharge and abstraction. And where I sit in Southern Africa, there are a lot of aquifers, and there is an ongoing narrative that there's lots of water, they're just not accessing it for agriculture, essentially, since most hydro is surface water. And it feels like this is somewhat disingenuous because, of course, aquifers are very sensitive creatures and have to be treated with a lot of respect. So you need data to know how much respect you need to issue a particular aquifer. And I'm interested in the costings because, of course, a private company is probably not going to pay for this based on how agriculture is done in the region. It would be the government, and then hopefully this would feed into licensing and other requirements, and then potentially even modeling around, well, if you protect this particular landscape, you increase your retention and refill by this much. So sort of those trade-offs within a landscape piece. I don't know if you've done that modeling as well.
To be honest, again, I'm not the person running that particular project, so I think probably I'm not aware of the technical details specifically of how they are doing this. So I think this is something we need to discuss with my colleague Andy Ball, that he couldn't make it today. So I'm afraid I'm not going to be able to answer your question on that one. Sorry about
that. It's okay.
Okay, I think we'll just wait a minute, just if there's anyone else that's wanting to join for the next module, and then we'll hand over to Juan again. Thanks. Okay, we are ready for our next slot with Juan, who's looking at digital tools for efficiency and leakage analysis. Up to you.
Thank you. So welcome again. If you were following the previous session, it's me again. But this time you can ask difficult questions because this is my own topic. Okay, so please make me difficult question this time. I will be happy to have them. So we are going to be talking here about some tools to increase the efficiency. We've developed a tool called Simon Water, Simulation Online, and it's actually targeting specifically helping water companies to be more efficient, okay, by tackling or helping them to tackle leakage in those water supply systems. I don't think we need to specify or tell people why reducing leakage is important in water supply networks. We know all that water is a very scarce resource, that obviously losing water, it has a monetary and environmental cost because of that scarcity. We will be wasting energy when we are losing water because we treat it, we pump it, and we are going to increase our CO2 footprint for all those reasons when we are losing water in our system. So it is essential that we keep leakage to a minimum. We all know that, and there are many other reasons that probably I'm forgotten it today. We all know that, but why there are still a lot of leakage in our system? Obviously, it's a complex business. It's an infrastructure that's underground, and unfortunately, there are no magic wands. Okay, there are no tools that will help all your problems. Even ours is just one of many tools that you will need to use to get into this problem. To detect leakage is doable, it's possible, but you need to have teams on the ground, and then this is going to be always time-consuming, and therefore it's going to be very expensive. So having very good and efficient strategies and tools that help you to guide you how to deploy and where to deploy those teams are essential. And especially because of a key reason that this is a never-ending task, okay? War on leakage is something that will never finish because new leakage will continue to appear, and therefore early detection and location are essential to mitigate their impact, okay? So what we've proposed after talking with different experts in the UK and Italy, we've come up with a double step tool, two-steps tool, which we've got a leakage detector, Simon Water leakage detector, which what it does is fed by the data that you've got in your water supply network for all the sensors, or flow sensor basically. It creates an alarms on daily basis when the software detects that new leakage are occurring, okay? And then it gives you a tool that prioritizes in which district meter areas or trunk mains you need to send those teams to try to investigate where they are, okay? We only need flow sensor data. Obviously, there are some technical requirements. You need to have enough flow sensors on those areas. We don't have time today to enter into these technical specifications. But once you've got enough sensors, or your network, it has a particular structure that you can get into, then you can do this analysis. And there are different analyses depending on whether you are in district meter areas or trunk mains. Once we've detected a new leakage happening, then this tool automatically cascades to the second module, which is the leakage locator. The leakage locator is our contribution trying to find a magic wand that it will tell you, hopefully, where this leakage is more likely to be. It's not going to be perfect. It's based on a lot of assumptions. You need additional data, particularly pressure sensors distributed in the network, and you need to have a calibrated hydraulic model, okay? So there are a lot of technical requirements, but if you can match all of those, we have a tool that will help you to narrow the area where to look at, okay? All this technology now, because the market is changing, and especially in the developed countries, smart meters are getting into those systems. The tool can support also smart meter, and we are doing a research project now with UKWP, where we are actually modifying the tool so a smart meter can be used also on the calculations to detect the leakage into the system. These tools are all web-based tools, automatically working. The idea is that they repeatedly work every day and do the calculations every single day. And they need to be very practical, easy to use and install. And again, I know I will be criticized for that, but it is a very affordable tool. I am bearing here in mind the prices of similar tools that don't do exactly the same, but compare it to that one. We are running now, or are starting to run some pilot studies in places like Thailand and South America. So one of the key aspects that they attract our potential collaborators, that they are affordable. Just one mention, the leakage detector tool is commercially available now. The leakage locator tool, it is work in progress, and it is going to be finished by the end of the summer. So the methodology is tested. We are wrapping up the interface. So I want to show you some images of the tool. So it's a web-based tool where you might have, in this case, district meter areas, and you've got different colors showing the priority, which ones are performing worse and which ones are performing better. This picture will change every day because there is an analysis done daily. And as I mentioned before, that can be used for distribution areas, or it can use as well in trunk main. So if you are looking at transport water from one area to another one, we could also use these tools to analyze any problems. The point here is because it's automatically and it's done repeatedly every day, you will have a lot of calculations based, space in time, where you are estimating, and we come back to this one. This is an estimation. It's impossible to know 100% what the leakage of the system is, but this is an estimation. And there is an uncertainty associated to this estimation. So the important thing here is to see the trend. You can see here, I'm not sure if you see the mouse in the screen, but there is a moment here where the system is ramping up, and there is a clear change in the way that the leakage it is calculated, estimated. So there is a new leakage developed there, and then you need to send the teams to repair that area. The sooner you detect it, the better, because you are losing water in the meantime. And then once they repair it, the good thing of this tool as well is that it helps you to see how efficiently your repair it is. You can see in this case that there are kind of 2 or 3 steps trying to come back to the same level of service, but they didn't get there. So maybe there were several leakages, or they didn't repair the right one. So this analysis done every day. This is an analysis that the water companies maybe don't do once a year or once in a blue moon, every several months. But if you do it every single day, then you've got more points, and you can understand quicker and better what are these trends. Because all these calculations of and estimations of leakage are assumptions, are estimations, and then you need to have all these points to see the trends and see how they are changing. Okay, so again, this is an example of all the inflow data that you are getting. So the tool is very simple. With a couple of hours training, the operator will be able to understand how it works, and even if it uses quite complex methodologies and statistical analysis, it will be very helpful for them, because it will help them to prioritize every day where to send the teams to analyze or to investigate the problems on the ground. The incoming new tool, it is not ready yet. I cannot show you any screenshot, but the idea would be something similar. So I've detected that in one of these polygons, for example, this red one, there is a problem. Automatically, a hydraulic simulation it's launched, and then, oops, I want to come back. And then a hydraulic simulation is launched. Some hydraulic calculations are done, and then in this network that, for example, is 65 kilometers long, the software is telling you to look into 4.5 kilometers. So it's reducing 90%, more than 90%, the area you need to look into. So a job that maybe would be a 1 week work for the team can be reduced in 1 day, so then they can move on to the new system. So this is the idea of the tool, helping you and the water companies to be on top of the game and trying to fix leakage as soon as possible. Because this module 2 it's work in progress, and we need to we've done some methodology testing with real case studies, but we want to do more with real data in different parts of the world. We are launching a campaign to test this in different places. So we are asking water companies to help us and to become partners to test this module 2. We do have already commercial clients in Italy. We have already some systems that we've tested in the UK and in Italy, but we are actually in conversations to start 3 systems, one in Argentina, which actually I am flying on Friday. I think Sonia is watching this presentation from the embassy in Argentina. So I will be there next week talking with a company about this pilot. but we've got another incoming probably in Thailand, another one in Hong Kong, and then we are in a lower level of still very early discussion in other parts of the world. I forgot to mention there also South Africa, that they were in the UK visiting and they like the idea. So please, if you know any water company that could be interested on testing this methodology, we are really looking for partners that would like to test it. These tests are for free. We offer them freely available for people that are helping us. And then at the end of the testing period, if you like it, obviously you can buy the system. We are not going to put any problems with that, but we really want to test it in as many different conditions and different countries as possible. So please send me an email if you think that could be something relevant in your territory or in the area you are working. And I think that's it. Again, yeah.
Thank you. Again, yes, if anyone has any questions, please raise your hand, pop it in the chat.
I have a question in the room, if I may.
Yeah.
In condition assessment of water supply networks, leakage is obviously a big data input in what we're doing in assessment, and often a driver of why we're doing it. And there are three questions usually we like to ask and get answers for. One, are there leaks? Secondly, where are they? And then the third is, how big are they?
Mm.
How many of those questions are you answering? I can see two. Do you intend to go and answer the third as well?
I think we answered actually the three of them. Can I use the mouse? Sorry, 1 second. If we come back to one of the slides. I hate this. So the leakage detector will tell you where they are, in which area, no? But it always will estimate the value. This is what we are showing in this graph here. So this cloud of points is actually a numerical estimation of a leakage in that point. And this is actually the boundary condition I am using in my model to try to locate it. If I didn't know the amount, I couldn't even dream to guess where it is. Okay, so by analyzing the different sensor data, and in some cases doing a mass balance, if I know all the input and all the output, by doing a minimal night flow analysis, if I don't, probably you know that better than me, we can come up with some methods to estimate those losses. Are going to be wrong because the absolute value is not going to be that. But what we are after here is the trend, because I always more or less get it wrong around the same value or oscillating around a particular value. So I think hopefully we could help you with the three of them. It's a matter of the size of your DMAs, of the accuracy of your sensors, and the size of the relative size to see how accurate or how low we can go compared to the minimum night consumption. No?
It's not always absolute numbers that we want. It's trends, as you say, and often it's relative situations, so we know which ones to prioritize.
Mm-hmm. Yeah,
you know, this is a big leak, this is a small leak. I'm not going to argue what the actual value is. Okay, thank you.
So I think the key point here is the module one is not rocket science. It's something that is best practice. Everybody does. I think the advantage here is it is done automatically every day. So you've got more of those points. And then it's in a web environment, so it is easier for access to anyone in the water company or in deciding to study that. There are no expensive licenses that only few people can access or understand. So everybody could be looking at that. So I think this is the 2 points. And then a very clever way of statistically analyzing when you raise the alarms, okay? Because there is some uncertainties and there might be some variability in the data. I don't think you can have like a trigger value that is a constant leak. No, it depends on how your data is oscillating. You can see that our bands are increasing or decreasing. Depending on the variability of your data, you need to be more flexible or less flexible before raising an alarm. Okay,
thank you.
Very good question. Thank you.
Are there any other questions online at all? No, we did have a question that was asking the outcomes of some of the pilot studies. Able to share that?
Yeah, so the first outcome that we usually get when we install it in someone company's system, they find out things they didn't know. Okay, anything that helps you to use your SCADA data. SCADA data is a bit like a Chinese vase. people have it there. A lot of times they don't know what to use it for. You know what I mean? It's like, oh, this is very beautiful, very expensive, but what shall I use it? So anything that you can do with this data and try to get something meaningful helps the teams to understand and to know better their systems. Then in some of the, I think the innovative part of this tool is going to be the new module that we are releasing at the end of the summer. The test we've done in real case scenarios where people were opening hydrants during the night and not telling us, and we had to tell them where they were doing it. It was a bit of a seek and hide and seek game. It was really fun because they were telling us, this is really good. This is saving us, a lot of time. If we had to look for this leak in our system, it would have taken us a week, 2 weeks. And now we are narrowing to something that we can do it in 1 or 2 days, okay? There are a lot of technical restraints, so you need to have your hydraulic models, you need to have enough density of pressure sensor, you need to have DMAs, that not all the countries have district meter area. But if you have those, or if you want to apply it to trunk mains, which in a way are simpler conceptually, I think the savings you can get are amazing. One of the clients I was talking the other day, they had a leakage in a trunk main, which was going to the sewage system. They had it for months, massive. They were losing a lot of water, and they never even noticed it for many months because they didn't have any tool that helped them to monitor these things in real time. Okay, so you can save a lot of money and a lot of water, which probably is more important in places where it's a very scarce resource.
Yeah, the other question was, do you see these tools being used by UK water utility companies?
I would love to. Yeah, we do have one of the pilot was done for a UK water utility company. We are doing this research project now with UKWP, and hopefully we will be showing some of the potential of this tool. And directly, it's not the objective of the research project to show our tool, but I think we will do it, especially because we are allowing now the input of smart meter data, which I think is going to change. So the smart meter data will help us to do mass balance in DMAs. But until we arrive to 100% penetration, we might need to do some hybrid method where we do minimal night flow, but with the part we don't know. So we've developed a hybrid methodology there that I think could be very interesting. The only problem in the UK is people tend to have their own tools, and it's very difficult to change the way they operate. While when we go to other countries where maybe they don't have a tradition to use these tools, they are more open-minded and more flexible to try new things. We found it a bit difficult, the UK companies, because it's really difficult to change their mindset on the way they do things. Yeah. But I don't lose the faith. Yeah.
Great, thank you. I'll just leave it a minute just to let anyone else join from the Red Room before we move on to our next module. Okay, we're just going to move on to our 6th module, which is looking at managing resilient systems. And we have Tom with us today talking about preventive management of critical infrastructure and gravity sewer inspection and condition assessments. Tom, over to you.
Hello, everybody. I'm very pleased to have the opportunity to speak to you today about this. Just a quick introduction to us as a company. We are a consulting engineer. In that respect, we're like Arup. That's about where the resemblance ends, where Arup is several thousand people. We are fewer than 10, but we're a small team of specialists with lots of accumulated experience in this particular area of trenchless technologies, and particularly this inspection, assessment, and rehabilitation of existing networks. The case study today is specifically on a gravity sewer. It's quite a straightforward example of the process and the way we arrive at solutions. But it applies equally to water networks, the things that Juan was talking about earlier on. Leakage is a big thing that drives us in water networks, and also in sewer pressure mains, sewer rising mains, force mains. They're probably the biggest nightmare in any networks that we have to deal with. But the general process of assessment, our experience and our knowledge applies across all of those networks, but we'll take a gravity sewer as an example. So it's our speciality. All of our team are focused on this area in different parts of the world. We work, even though we're a small company, we work across the world with about 30 years of experience. Specifically in solving problems. We're not really looking at big picture issues. We're trying to solve specific problems. It's great to know you have a problem, but then you have to solve it. So that's what we like to do. We're problem solving engineers and like to get our hands dirty. And the process of condition assessment is a step-by-step process like this. And there's a great temptation when somebody thinks they have a problem to jump straight to a solution without really first knowing what the problem is. They know the answer without really knowing the question. And that doesn't work. That's a recipe for disaster. So it is a step-by-step process. And we start with looking at the problem, a data audit, risk assessment. What do we already know? What information do we already have? The original specification, as-built drawings. We build up a picture. It's like creating a jigsaw puzzle. We have a few pieces, and then which pieces are missing. So then when we know what we still need to know, that's when we look at the field investigation and the inspection and potentially going into the field with leak detection if it's a water network. Just to fill in the gaps in our knowledge. And it's very important also to understand the difference between inspection or investigation and assessment. Many people see them as one and the same thing, and they're not. The inspection is acquiring data for the assessment. Part of what Juan was talking earlier in the software starts to combine the two, but we need to take that data, what we know about the condition of the network, how it's performing, and risk levels, in order to perform a proper assessment and then decide which are the right solutions. So that's generally the process. In principle, applies across all types of underground networks, but we'll take one particular example just to show how it was done. And it's a fairly straightforward one. So we're looking at a trunk sewer in Riyadh, capital Saudi Arabia, large city. So this is typical of any large city. Major trunk sewers in the center of cities, they're not easy to get at. You're not going to dig them up and replace them. It's too disruptive. So you need to work with the assets you've got, and whether they're relatively new, as in this case, or relatively old. The asset really is the hole. The liability is the pipe around it, and you need to manage the liability in order to get the best out of the asset. This situation, major highway, several intersections. To make it even more exciting, you'll see in a moment, there's a big stormwater culvert right above the sewer, also underground, and any failure would be catastrophic. We didn't have a lot of information. We've got lengths there. We know what the materials are. We know the diameters. But we had to work from there. We had some original specifications, some original drawings, not as built, So we knew, or we thought we knew, what the thicknesses of the pipes were. We could do some calculation on how they would support external load. For this particular situation, our sewer is the relatively small pipe at the bottom there, the round one. Above that is this very large reinforced concrete stormwater culvert. It's about, this is not to scale, but it's about 2.5 meters high. So when there's no water in it, we don't have much in the way of external load. It's nicely bridging the sewer for us and taking traffic load away. When it's full, we've got a lot of external load. So that made this one somewhat more complicated than usual. We were helped a little bit by the fact that the groundwater was generally below the invert of the pipe. Groundwater is often our biggest enemy, both in terms of the loading and obviously for hydraulic reasons, it infiltrates into the sewer. So this was the general setup. The stormwater culvert in the end was where we had to work from to do the inspection work. So we needed to understand the condition of predominantly asbestos cement pipes here and quite large diameter. We need some inspection after we'd done the first data audit, and what was chosen was, in this case, a mixture of CCTV, which is almost always used in gravity sewers. We wanted laser profile as well, so that we could see and quantify any corrosion in the upper part of the sewer. And then we wanted some sonar to understand what was going on below the surface, because we could never get this sewer empty. We were concerned about corrosion because the pipes are either reinforced concrete or asbestos cements or cementitious materials. The sewer flows a little under half full, but very, very slow flow. It's a septic situation, hydrogen sulfide is created, and that very quickly corrodes the crown of concrete sewers. So we wanted to understand and quantify that. So we've done what's on the left-hand side of the chart there, some engineering data from the pipe characteristics. Then we needed to add inspection data to that from the field inspection. And, you know, field inspection, as much as necessary, as little as possible. It's expensive, so you don't want to do any more than is necessary to fill in the gaps in your information to give you enough to do the assessment and the analysis. This is the type of output you get. So this particular one, we got the visual, and you can see even from that, there's a lot of corrosion of the concrete there. The laser profile, it gives us some quantification of that. And the worst condition, we had depth of corrosion was about 42 millimeters, which was more than half the thickness of the pipe. And then the line across the bottom, that's a sort of a development of the pipe. The invert is in the middle, and then the spring lines are top and bottom. And those red and yellow areas are the amount of corrosion, and then the black is siltation and debris in the invert. So we're getting a picture of what's going on in this pipe from these three sources in the one tool. I have to say, it's a bit of a multi-tool like that is a bit of a compromise. It's a reasonable camera, it's a reasonable sonar, it's a reasonable laser. But if you did the three separately, you would probably get each individual bit of data would be a bit better, or a lot better. But again, it's cost, and is it good enough? And the answer is yes. Now, what do we do with all that data? Well, this is an example of how we did it at the time. It's a sort of a Bayesian algebra approach of different inputs. We can work without all of the inputs. This evolves, we do it slightly differently now. But essentially, you've got to take all that input data from various sources and pull it all together to understand the condition of the assets, but also alongside that, how that condition affects the performance of the assets, because that's really what the owner wants. He wants assets to perform, and the condition needs to support the level of performance they require. If the condition starts to fail, you don't get that performance. That's, if you like, a consequence of the failure. So we start with this, we look at likelihood of failures or likelihood of occurrences. Alongside that is consequence, and that gives us a risk analysis. So we might get an output something like this. The one on the left is what wall thickness we need, and that culvert above is full of water. What's the minimum wall thickness of AC pipe? It's very simplified, just to show it quickly on this slide. And what we're able to work through the whole process, we come out at the end with what was on the right of this particular case, which is for each diameter and material, we're able to assess low, medium, or high risk and allocate the length to that. And as you can see, the 2 meter diameter reinforced concrete was all low risk. The big risk, lots of meters of red in the 1700 and 1400 asbestos cement. So there we can see, where the problems are. There's a bit more behind this. We can see the distribution is all of it in one area. In this particular case, it was distributed really throughout the pipeline. So now we begin to build a picture. We have enough information to understand what sort of solutions are available to us. So the options we considered here were full structural rehabilitation of all of the 1700, 1400 and 1200 millimeter AC pipe and just joint sealing in the 2 meter, which was in generally fairly good condition and low risk, or full structural rehabilitation of the 1700 millimeter, which had a lot of high risk pipe, partial rehabilitation of the other 2 diameters of asbestos, and again, joint sealing. And partial rehabilitation means patching and doing a bit here and a bit there. You could do maintenance and monitoring, just carry on monitoring it, see if it's okay, see if you can live with the condition, bit of patching up as you need to go. There's always a temptation to say more investigation. If we have more investigation, more data, keep on inspecting it, we'll be able to come up with much better answers at the end. Quite frankly, you can spend an awful lot of money and waste an awful lot of money doing that. There's a point where you have to fill in the gaps with engineering knowledge, expertise, and experience. Otherwise, you get perfect information and anybody could figure out the answer. You don't need engineers anymore, which would be a disaster. And there's always the option of doing nothing. And it's one that utilities sometimes take. Well, we'll wait till something really bad happens and then we'll do something. Not recommended, but it's always there. So what we decided or recommended in this situation, because of the distribution of the deterioration, it wasn't concentrated, it was spread throughout the pipes, was a full structural rehabilitation of the 1700, 1400 and 1200 millimeter, joint sealing where necessary in the 2 meter diameter pipes. And the proposed rehabilitation method was a spiral lining. Now, this is a PVC profile, proper structural profile that is able to be created in a spiral and essentially spun out inside the existing pipe. The annular space between that and the hose pipe is grouted, and that gives you a structural rehabilitation. So that's just one example, very quickly and quite superficially, of the process. But it's important to stress that don't leap straight to the answer, because there's a big chasm between the beginning when you know your problem and what the solution may be, and you don't want to fall into that chasm. So that's just one example, and thank you.
Wonderful, thank you, Tom. Are there any questions, anyone online at all? Again, please raise your hand or you can put them in the chat. What we do have.
Can I have one question?
You got one, go for it.
So Tom, how did you get this project? So how does the client decide that they need to call the A team and fix the problem?
Unfortunately, it's usually a good disaster focuses the mind wonderfully. They will have had a problem somewhere, a sewer will have failed, broken, probably as happens with water mains as well. So it varies from utility to utility. Some decide to take a proactive approach, but generally it's the catalyst right at the beginning is something bad happened.
But in this real project, there was no disaster.
No, there wasn't any disaster, but I think if I remember rightly, in that particular project, they'd had a sewer breakage in another pipeline, but of similar material, so the similar cohort of materials. And they looked at this, this is similar material, high risk location. So they saw a high consequence of failure. Sometimes that starts it off as well. They start to look, what has a high consequence of failure? And if the consequence of failure is high, then there's a high value in knowing the likelihood. So sometimes it works through that way, but usually at some point something really bad has happened, and that focuses the mind. A bit unfortunate. It turns us into ambulance chasers, if you like, but that's just the way it is.
We did also have another question. Sewer repairs are expensive and can be complicated. What are your views about the need and feasibility of doing this in a country with ageing infrastructure such as the UK? Should there be a focus on building new infrastructure?
It's several questions, that is. What are my views on rehabilitation of ageing infrastructure? I would say, as I said a little earlier, the whole is the asset. That's essentially what the utility owns. The problem is the pipe around it. So absolutely, where your infrastructure is aging, no matter how bad condition it is, there is usually a way of restoring its level of performance. Now, that may well be, in some cases, putting new infrastructure in the ground. But the reality is, in large cities like London, where we're sitting, you're not going to dig up all the streets to replace all, especially the sewers. They're the biggest, they're the deepest pipes of all. The sheer disruption is just not on. And there are a lot of technologies now and a lot of knowledge in how to avoid doing that. And although the water utilities in the UK get a lot of stick, there are some really clever things being done in London, especially, but around the country as part of their sewer management programs. So absolutely, where you can manage and get the best out of the existing asset, the technologies are there now to do that without digging everything up. And I would always look at that, if you like, as the first option, not the last option.
Great, thank you. I don't think there are any questions online. So again, we'll just pause for a few minutes until the next session. Thank you. Okay, so if we move on to our final module, we have Justine with us. Hi, Justine, talking about managing resilient systems and demand management. Welcome, Justine, and over to you. I'm able to click through slides for you, or you can take control. It's
brilliant. No, that's fine. I'll leave it to you. Okay, so hi everyone. If you just go to the first slide.
Yep.
So hi everyone. I'm Justine Leadbetter, a senior consultant at WRC. I head up the leakage and water resources area, and I'm going to talk to you about non-revenue water and some of the capabilities we have here at WRC. Okay, next slide. So WRC is a consultancy based in Swindon in the UK. The company was originally formed in 1927 and was a government agency until the water industry in the UK was privatised. We cover a wide range of topics, but tend to focus on research to solve water and environmental sector-wide issues. And there are a range of different technical experts here, and as well as physical testing facilities to support our research, and a library of data and research that we can draw on to drive improvement sector-wide. So we're constantly looking for ways to innovate and make a difference, for example, using machine learning and data science techniques. Next slide, please. So WRC has a rich history in non-revenue water. So currently our managing director, as well as two of our other directors, have a leakage background, and a number of other individuals around the company too. So this has resulted in our involvement in projects with a wide range of drivers. So we frequently contribute to industry leading work such as the Water UK route maps, driving forwards both leakage and consumption in the UK. And we have experience both here and also internationally. So we're currently doing some work in Oman and earlier this year in Brazil as well. We frequently provide strategic and tactical advice for non-revenue water management. We support regulators and contribute to standards and guidelines as well. But one thing that kind of separates us to some other consultancies is that we operate a collaborative research program where companies come together each to part fund a piece of research as part of a portfolio project. And this is one of the key ways that we can promote and contribute to innovation and learning across the sector. So non-revenue water projects recently have included work looking on ultra low loss new networks, which is a bit of a mouthful, but it was a very interesting project. And then finally, because WRC has a fieldwork part of the business called technical services, we're then able to join together the data side of non-revenue water management, as well as the fieldwork side, to allow for a data-driven NRW investigations. And so this is the example I will expand upon now. Next slide, please. So one of the key problems when managing non-revenue water is trying to differentiate between real and apparent losses. So those losses that are physical leakage and those that appear to be losses, but are due to, for example, metering error or meter under registration. And this is what we've tackled in our upstream losses projects, which we've delivered for a number of different UK water companies. This project focuses on losses occurring upstream of DMAs. However, the theory can be applied throughout the network. So we've created flow balances for discrete areas, looking at water in versus water out, considering the systematic error of meters. And then from this data analysis, we are then able to indicate whether there are real or apparent losses, and then recommend a prioritised list of interventions, which could range from meter verification all the way through to mains renewal of a section of pipe. And then depending on the recommendation, we'll then work with our field teams to carry out these interventions. For example, maybe some leakage detection surveys or condition assessments, or do some meter verification. Next slide, please. So following this methodology, we can then quickly identify those quick wins, both in real and apparent losses. So in this case study, we produced over 600 balances in 6 months, and then produced intervention recommendations for assets in each one of those balance areas. So for example, we were able in one of those areas to identify 2 megalitres per day of physical losses on a single section of trunk main, and then we were able to validate that by inspection. the project made the most of all the data sources we can get. Obviously, the more data, you can maximize your insights and then also increase your confidence in the recommendations. So we were pulling from flow data, meter asset data, and any relevant meter performance data, reservoir level data, repair history, GIS asset location data, and network schematics. Next slide, please. So this is what we produced for each of these balance areas. So the graphs could then be used to indicate whether the losses seen were real or apparent, or whether there was unmetered consumption, and so whether a new meter needed to be put in. And then all of the recommendations are within the table at the bottom, which as well as an indicative cost to aid in strategic decision making, so that the company can then work out which of these, both from a losses point of view, which would be the priority, but also from a budgetary point of view. So overall, this allows for a far more holistic approach for reducing non-revenue water, using both data and fieldwork-led approaches. It can also be used in an iterative process to drive continued improvements from data production and management through to the physical leakage identification. So, for example, if you go out, if you recommend for a meter verification, the meter can then be verified, you can rerun the balance, and then you have greater confidence whether there are or aren't losses in that area, and you can reduce both your real losses and apparent losses continuously over time. Yeah, thank you.
Great, thank you, Justine. Again, if anyone has any questions, please do raise your hand, or again, you can pop them in the Q&A chat if you'd rather. We do have one question already that was submitted before the event, and that was just, what are the greatest challenges around fixing leakages in the water network in your view?
Biggest challenges? Well, I think there are so many challenges, both in probably, I know in the UK there's you get monitored on how long you, like interruption to supply, and that's a big issue. So if you have your interruption, if you're monitored against interruption to supply and you have a long-standing leak that is just continuously long running, however, in order to fix it, you need to switch off supply, but then you could get penalised for that. And I know that's a very UK-based one, but I also think that is an international problem. It's going to be a problem anywhere. In order to fix some of these leaks, you need to switch off supply. And for example, if that supply is leading into a hospital, then that's going to have such major implications that you're going to really struggle to be able to repair those leaks.
Great, thank you. Anyone else have any more questions? But if you don't have them currently, you can always get in touch with Justine, I'm sure, at a later date and send her the questions. Please have them. Okay, I think that's everything. Thanks again, Justine.
Thanks very much.
Okay, so that is all from the Blue Room now. Thank you all very much for joining. This is a QR code to a feedback form. Oh, sorry, Jermaine. Question?
So sorry, very, very slow at getting the mute button.
Please don't worry.
Cheers. I was really interested that you said WRC pre-privatisation was a UK government body, and that you do sort of more than just private sector work. And I wondered if you could talk a bit more about that and how you may have done that with developing countries, if at all. Thank you.
Yes, so now that WRC is kind of a private company, it's consultancy, we will kind of the international tenders that come out, we will bid on those, but also we've been in recent years, we've been expanding and trying to look more internationally. So we've been doing a lot of work in the Middle East, working with regulators, quite a lot of work with NEOM as well, but also with the regulator over in Brazil. We tend to, in international work, do a lot of kind of knowledge transfers to try and help build knowledge across the world. Yeah, just kind of a bidding for the work as and when they come up in the same way. But yeah, I hope that answers your question there.
I think it does, in the sense that it's bid led as opposed to there being some kind of peer learning or other, I'll call it non-remunerative added value within the sector, especially in countries that are coming more online with this, but do not yet have necessarily a lot of infrastructure or technical body experience.
Yeah, so I mean, we've done work with the Department for International Trade, where we've done some research looking at where the UK water sector could kind of, in the UK water industry, could get most involved and be able to provide knowledge and aid in that way. But no, normally it's kind of getting a project in a similar way that we would in the UK. It might be through a previous project that we've run that someone has heard of, and we're approached out the back of that. But it tends to be along that line.
Okay, thanks. Yeah, I spotted on the slides that you'd done something with FCDO Brazil, and I wasn't entirely certain what, but it sounded like you do more than many other types of company, which is why I was interested. Thank you.
I can reach out to you after this with any more details on some international kind of international case studies, if that would interest you.
Yes, I'm always interested. All the talks have been very interesting.
Great, thank you. Yeah, we will just ask, if possible, if people wouldn't mind, leaving us some feedback on the workshop, letting us know what went well, what didn't. Just any comments would be more than welcome. And thank you again to all the presenters. Thank you again for attending. I hope you have a good evening. Thank you.